Following on from the previous two videos, I've shown you how you can combine your normal standard sine graph, looking like this, and combine it to y equals x graph, to create a sine wave where the amplitude keeps on increasing. Now in this video, we're going to look at what happens in the negative realm. So this at the moment, this red line here is y equals x sine of x, and this here is 360 here. So one period is like this. Well, on this scale, it would look something like this. Remember, this is 0 to 90 here. So so your sine graph, one would be really close to the 0 here. So your sine graph will probably look something like this. You probably won't notice it, but it hovers. You see, one period. Sorry, one period is like this, and your normal sine graph will look something like this. Actually, it will look something like that. So it will look something like this. You see, this is 360. This here is 360. This here is 180. This here is 90. Okay. So your normal sine of graph will look something like this. Will look something like this. Okay. But then we're combining x and sine of x. So it's really this block multiplying with this block. So we are combining our normal sine of x graph, which is this purple line here. We're combining it with y equals x, which is 180 here, 180 here. Move across, it will be here. 270 here. Move up, 270. So our normal our y equals x will look something like this. Okay, and then this is 450. 450 here. That's why the amplitude here is 450. Well, anyway, now going into the negative realm. Remember, our sine of x graph looks something like this. It will look something like this. It will be a straight line going through the origin like this. Now, our normal sine of x. I'm just going to exaggerate here. Hang on, sine of x will look something like this. Hang on, it will look something like this. I'm exaggerating the height here. This is one period, and this is one. So going back down in this direction, it will look something like this. Okay, this is another period here, 360. But I'm exaggerating the height. You see, at this point here, with our we are trying to look at y equals x sine of x. So really, it's this block multiplying with this block here. Now, looking at this here, this at negative 90, this block here will be minus 1. But then looking at this here, remember your line y equals x will look like this. This bit here will be minus. Well, looking at y equals x graph. Y equals x graph will look something like this. Okay, this here will be minus 90. So looking at your y equals x, it will be at this point here. It will be minus 90. So now this times this. Well, 90 times 1, that's normal, would be 90. But then two negatives would be a positive. So it would be a positive 90. That's why rather than being amplified in this direction, in the negative direction, you're actually amplifying in the positive direction. So it's up here. Okay. Well, 180 would be 0, so it's always 0. But the thing is, now looking at negative 270, well, the sin x part, will be positive 1. The sin x part will be positive 1. Okay, this is the sin x part at negative 270. It's right here. It's positive 1. But then looking at the y equals x graph, is like this here. At 270, it will be negative 270. So the x part will be negative 270. So this here is your x part. This here is your sine of x part at negative 270. So now combine the two. This times this, it will be negative 270. So even though the sine x part is in the positive side, when you combine the two, it will take you to the negative side. So it will be like this. So overall, your graph looks like this. So just looking at the sine graph, the sine part, it will look something like this. Me exaggerating the height again. This height here should only be 1, but on this scale from here to 90, it's a bit unrealistic. But I just want to illustrate it to you here. So this is our normal sine graph here. Notice that this bit here, it gets inverted. So this here gets inverted. Well, if you extend this, it will look something like this. You see this here, inside our mind, we would think it would move all the way down here, but no, because your y equals because this y equals x here is in the negative direction, rather than it being stretched in this direction, it's actually being flipped in this direction. Okay, so my point here is that in the previous two videos we only looked at the positive side. Okay, y equals x will look something like this. Y equals x will look something like this. But then now in the negative side, notice that things are being flipped because y equals x here on this side, in the negative realm here, you're going to have a negative number over here. That's why everything's being flipped. Well, anyway, so your y equals x sine of x will look like this. Okay.